VR headsets for medical training and simulation. Title: VR headsets for medical training and simulation, revolutionizing healthcare education. Introduction. Virtual reality, VR, technology has garnered immense popularity in recent years, altering the way we perceive and interact with the digital world. While its application in the entertainment industry has been widely recognized, its potential in other fields, such as medical training and simulation, is now being explored. VR headsets have emerged as an invaluable tool, allowing medical professionals and students to learn, practice, and refine their skills in a safe and immersive virtual environment. This article discusses the profound impact of VR headsets in medical training and simulation, highlighting their benefits, challenges, and future prospects. Enhanced visualization and immersion. One of the primary advantages of using VR headsets in medical training is the ability to visualize complex anatomical structures and medical procedures in an immersive 3D environment. Traditional HUDs often rely on textbooks, diagrams, or static models, which lack the dynamic and interactive elements necessary for a comprehensive understanding. Realistic simulations and hands-on experience. Incorporating VR headsets in medical training allows for the creation of lifelike medical simulations. Trainees can practice a wide range of procedures, from simple injections to complex surgeries, and a virtual setting mirroring the conditions of an operating room. This hands-on experience in a safe and controlled environment significantly reduces the risks associated with traditional training. Methods. Medical students can gain confidence, develop muscle memory, and refine their techniques without compromising patient safety. Interactivity and personalized learning. VR headsets encourage active participation, enabling trainees to engage with virtual patients and scenario-based exercises. These interactive experiences present users with a multitude of decision making opportunities, mimicking real-world medical challenges. Medical students can utilize their critical thinking skills, practicing diagnosis, treatment plans, and communication in a virtual environment. These simulations can be tailored to match the individual needs and skill level of each trainee, ensuring a personalized and adaptive learning experience. Objective assessment and feedback. Assessing medical proficiency is crucial for ensuring the quality of healthcare professionals. VR headsets offer a comprehensive assessment tool by recording trainee performance and providing feedback on their actions in real time. Metrics such as accuracy, speed, and precision can be captured, allowing educators to evaluate trainees objectively and identify areas for improvement. This data-driven an assessment method fosters continuous learning and allows for targeted training interventions, ultimately leading to better patient outcomes. Collaborative learning and telemedicine. VR headsets also facilitate collaborative learning and the exploration of telemedicine possibilities. Students and professionals from different locations can connect in a shared virtual environment, working together on complex cases and exchanging knowledge in real time. This collaborative approach bridges the gap between expertise and remote locations, empowering healthcare professionals worldwide. Telemedicine applications of VR headsets also allow remote patient diagnosis, consultation, and treatment, providing access to quality healthcare for underserved populations. Challenges and limitations. While the potential benefits of VR headsets in medical training are undeniable, there are challenges to overcome. Technical limitations, such as the screen door effect caused by the headset's race-all. Motion and field of view can hinder the realism of the virtual environment. Motion sickness or cybersickness may affect some users, reducing the comfort and prolonged usage of VR headsets. Additionally, the cost of implementing VR technology in medical education can be a barrier, requiring significant resources and infrastructure. Future prospects. Despite the challenges, the future of VR headsets in medical training and simulation appears promising. Advancements in technology, such as higher resolution displays and improved motion tracking, will address current limitations, enhancing the overall user experience. Continued collaboration between technology developers and medical professionals will contribute to the development of specialized medical VR applications, catering to specific educational needs. As costs decrease over time, VR headsets will become more accessible, widening their reach and impact on healthcare education. The use of VR headsets in medical training and simulation has revolutionized healthcare education. The ability to practice in lifelike simulations gives valuable hands-on experience without compromise. Patient safety. VR headsets also promote interactivity and personalized learning, simulating real-world medical challenges and tailoring the experience to individual needs. Trainees can engage with virtual patients and scenario-based exercises, practicing diagnosis, treatment plans, and communication skills. Objective assessment and feedback tools contribute to the improvement of trainee performance, allowing educators to evaluate trainees objectively and identify areas for improvement. Furthermore, VR headsets enable collaborative learning and telemedicine applications. Students and professionals from different locations can connect in a shared virtual environment, working together on complex cases and exchanging knowledge in real time. This collaborative approach bridges the gap between expertise and remote locations, empowering healthcare professionals worldwide. Additionally, telemedicine applications of VR headsets allow for remote patient diagnosis, consultation, and treatment, increasing access to quality healthcare for underserved populations. However, there are challenges associated with the use of VR headsets in medical training. Technical limitations, such as the screen door effect, can hinder the realism of the virtual environment. Motion sickness or cybersickness may affect some users, reducing their comfort and ability to use VR headsets for prolonged periods. Additionally, the implementation of VR technology in medical education can be costly, requiring significant resources and infrastructure. Despite these challenges,